we did R2 first, and then we rolled straight into R3. And all we mean by R2 and R3 is the two-dimensional space and the three-dimensional space. Two-dimensional space you're very familiar with because that's something you have worked with ever since you were introduced to the Cartesian plane, x-axis and the y-axis, very simple. And we use the I and the j vectors there, but we had to introduce a third vector, a third unit vector that we call the k vector. And each of these unit vectors can be put together to form position vectors anywhere in R3, right? And a position vector, remember, is a vector that runs from the origin to some point in space. So this point here, the ABC, represents a position vector from the origin down to the point ABC. So that's a vector right there, and we call it the position vector. So we've scaled the ijk vectors to create this vector down here. Now, remember that we can also come up with vector subtractions. Excuse me. We did some of that when we were doing the algebra. And I also made the point that, in fact, let me go to my next page, that you can do it just like regular algebra, right? So the vector, or the point 3 minus 1, 2, can be written as a vector by scaling each of these vectors, 3i minus j plus 2k. And I can write as a vector as well. Now, I use brackets. I've seen, I think in a textbook, they use round brackets. I use square brackets to make a distinction between a point and a vector. So this is a vector. When you see a square bracket, when you see me write a square bracket, Thomas is now checking in as well. So let me just mark Thomas here. Just give me a second. So everybody is now here. Okay, so I can close up that page now, since we're all here. Okay, so I was saying that you can easily, for me, when I'm writing vectors, you can easily see that it's a vector because I use square brackets as opposed to a point, like the point A, which is at 3 minus 1, 2, because I use round brackets for that. All right, not everybody uses that way of presenting it, but that's what I do. So then we talked about how you can add vectors together and how you can find also the magnitude of the vector. And we said that it was always just taking the squares of each of the components. It's really as simple as that. And I also showed you how you could find a vector between 2 points. So the vector which runs from this tail to this head, from this P to this Q, so here's your PQ vector. You just simply take head minus tail every time you want to find what that resulting vector is. So there's your magnitude. So let's just review from Friday. Sorry, where am I at Friday? Sorry, from yesterday, from Tuesday. Okay, so we started working on these and we didn't finish it. So let's finish this up, then we can move on to the other one. And the first one was the OG vector, the point G, the point, remember, point, if it's an uppercase letter, it means it's a point. Uppercase letter followed by brackets means it's a point. So the point is at 3, 1, minus 5. And from the O to the G, so that's a position vector, it'll be 3 times the I vector plus 1 times the J vector minus 5 times the K vector. And this would be the vector representation of it here, right? And that's all that is. OH, we didn't write the OH in because it's very much like the OG vector. So it's just going to be minus 1 times the I, and then there's no J, and it'll be minus 4 times the K. In fact, since I'm on it, I'll just put that in right now, right? Here's our OH. Let me fold this thing. A second, sorry about all the noise. Okay, so this vector, the OH vector, is going to be minus 1I. In fact, just minus I. I'll just write it. That's not an I, that's a J. So minus I, and then minus 4J, minus 4K rather. Right, there is no J that's needed for that one. And then also as a vector, square bracket, it'll be minus 1, 0, and minus 4. Right? The GH vector, I remind you, I take my H coordinates and I minus my G coordinate. Doing it the other way around would give me the vector running in the opposite direction. If I want to go from G to H, I start at H and I subtract G. So minus 1, minus 3, 0 minus 1, and minus 4 minus 5, which is how we got these values here. I made the point that, and I could put that again using the IJK, but I just took a pass on that because I think we're rushing anyway. And then we did the same thing over here, but this time we went the opposite direction. We went from G minus H, but I made the point that we could just simply take the opposite values of all of these to get this number, to get this vector rather. So 4, 1, and minus 1 is just the opposite sign to all of these numbers right here. Okay, let's get to the OG vector now. I like saying OG. Anyway, let's get to the OG vector now. We need to find not the, what we're trying to determine this time is the magnitude of the OG vector. Well, we already have the OG vector right here. It's 3, 1, minus 5, right? So remind me now, how do I get the OG vector, right? What do I do to get the magnitude of the OG vector? Anybody remember how that works from yesterday? In fact, I just reviewed that with you a few minutes ago. Distance formula. Thank you, Fernando. And the distance formula is very simple if you have the components, because what it's going to work out to is just simply squaring each one of these numbers. So remember, OG is this one right here. I'm just going to say 3 squared plus 1 squared plus minus 5 squared. It's really that simple. So that's going to work out to be the square of, let me do this in my head now. That's 25 plus 1 is 26 plus 9, I'm going to say is 35. But you should double check me on that. All right? I'm getting 35 when I do it. So that's the distance, and I leave it in that form, right? I don't need, I mean, if it can be simplified, I should simplify it, but I don't know any perfect squares that are multiples of 35. So I'm going to leave it as a square root of 35. Right? It's always best to leave it as in what we call exact form. All right. The OH vector, same thing. I'm going to take the square root of the minus 1 squared plus the minus 4 squared. Okay. And that would give me, let me see, 16 square root of 17 is what I'm getting from that. That doesn't look like 17. Hang on. All right. 16 plus 1. So in every case, all I'm doing is I'm just simply taking the components and squaring each of the parts of the components. Okay, the GH vector. We had the GH vector at the top of the page right here. So I'm going to do the same thing again. It's the square root of each of the components. So that would be minus. And I really don't even need to pay attention to whether it's minus or plus because I'm going to square it anyway. So minus 4 squared plus the 1 squared or minus 1 squared, doesn't really matter. Okay. Minus 1 squared plus another 1 squared. So for me, that's going to give me 16 plus, I guess that's 18. 16, that's 18 squared. But this can be simplified, and if it can be simplified, you should simplify it. I'm getting this as being, 3 root 2. Please make sure your skills at simplifying your radicals are in good shape. Okay, square root of 18 should be 3 root 2. Okay, how about the OG plus the OH? How do we do that? OG plus OH. Well, first of all, we need to figure out what the OG plus OH vectors would be. What vector is it that I'm talking about here? OG plus OH. Does anybody know what that vector is? Right? If I add together the OG and the OH vector, which vector am I looking at in that case? Root of, yeah, okay, fine, Taj, but I'm still asking for a vector representation of that. What's the OG plus the OH vector, right? Is there a way that I can represent that by just one vector, OG plus OH? Right? Is there a vector? Oh, you think it's the OH vector, Sarah is saying? The OG plus the OH? Okay, so you're representing it by, in fact, what we're really doing is adding the components together. So the components of the G vector are 3, 1, and minus 5. This H vector is minus 1, 0, and minus 4. We can actually simply add those components together. It's really, really that simple. So 3 plus minus 1 is 2. right? No, we're not working out the distance yet. We'll get to the distance later on, right? So I'll put that on the side there to make sure we know it's a distance. Then we're going to take the 0 and the 1, which of course is 1. And then we're going to take the -4 and the -5, which is of course -9. Okay, so that's adding those two. Vanessa is 100% right. Excuse me. The 2, and of course I should put this on the other side because we know eventually we're going to have to find the distance of that vector. Now, does that correspond to anything that we have already? No, it's just the sum of the two vectors, okay? So it's the 2, 1, -9 vector. But hopefully that makes sense to everybody, which is the sum of the OG and the OH vector. So the distance now would simply be the 2 squared plus the 1 squared plus the -9 squared. Okay, and for that, I'm going to be looking at 4 plus 1 plus 81. I'm just going to think about that for a second. 4 plus 1 is 5, 85. No, 86. Did I do that right? 81 plus 1 plus 4. No, plus 4. So it's 80. Yeah, 86. Did I get that right? I think I got that right. Okay, and I can't think of any perfect square. Thank you, Ashvan. I can't think of any perfect square that's going to go into that. All right. OG minus OH. No, there are two ways that we can think of this. Two ways we can think of this. We can just subtract the exponents, but is there one vector that would represent the OG minus OH? There is actually, right? If I'm taking the OG vector and I'm minusing the OH vector, can anybody think of a vector? Give me some letters now. And Thomas is saying it's the HG vector. Well, let's do this. Let's do this. Let's take the OG vector, write it as the OG vector, little arrow on top, and let's add on, not the OH vector, but what vector can I add on to represent minus OH? Okay, hold that answer for me, please. HO vector. Okay. No, and that's putting it like that. Is there, if I arrange it the other way, which is to put the HO vector first, and then add on the OG vector, right? And we've done this before, by the way. So if I take the HO vector and put it first, remember, when you're adding vectors together, the order in which you add doesn't matter. Subtraction makes a difference, but adding doesn't. So if I put it like that, if I go from H to O, then go from O to G, what is the vector that I'm going to end up with at the end of the day? And we've done this before. It's the HG vector, which, if you look back, is exactly what Thomas said a few minutes ago. It's the HG vector, not the GH vector. Let me be clear on that, because they're not the same. I want to be 100%, I want to be 100% clear on that, right? The GH vector and the HG vector are not the same. They're actually opposites of each other. They go in opposite directions. They have the same magnitude, but they run in opposite directions, right? So it's really the HG vector. So what Thomas said originally is 100% correct. No, Javier, thank you for putting that in, and Sarah as well. Now, we already have the HG vector right here, 4, 1, minus 1, right? So we can in fact put that in. And the other thing I should make the point of is that the HG vector is the same magnitude as the GH vector. They just run in opposite directions. So this answer that we have over here should be the same. But let's do this another way, right? If I wanted to take the OG vector minus the OH vector, I could have taken the points and actually subtracted them, the components. So for instance, OG is the first one, which is this one here, 3. Right? If I subtract these, so it's going to be 3 minus 1, which should give me the 4, right? The component 4. So I'm putting it as a vector now. So it should be 4. Then again, I'm subtracting. So it's G minus H. So it's 1 minus 0. So that's just 1. And then the third component, remember it's G minus H, would be the minus 5 minus the minus 4, which is minus 1. Okay? Now, that is exactly, if you look over here at the HG vector, it's the same thing that we had, 4, 1, minus 1. Right? Same thing here, 4, 1, minus 1. That's because to get the HG vector, we take G minus H, which is exactly what we just did. We took the G vector, we minus the H vector, and we get these same values here. So the answer that we got for the HG vector is the same we're going to get for the GH vector. Is going to be equal to 3 root the square root of 18, which is equal to 3 root 2. Right? Vectors which run in opposite directions, and they still have the same magnitude, right? Because one is just the exact opposite of the other, and that's all it is, right? So it's the same value of 3 root 2. Okay, so that's all I wanted to do to finish up this page with you, right? I think I'm just going to go straight into the thing that I wanted to get through today, and that really should take us no more than maybe 20 minutes, 30 minutes, which gives you enough time to get your homework done. So let's get to it. Unless there are any questions on the one we just did, right? I'm going to get to the other thing that we have on the agenda for today, and that is this. So we looked at algebraic vectors a few minutes ago, and yesterday we did the same thing. We'll look at some geometric vectors now. So we're going to understand again, so it's a bit of a repetition, right? We're going to understand a position vector in R2 and R3, like yesterday. Going to recognize the 3 coordinate axes in our form of what's called a right-handed system. We're going to find out what that means. We're going to be able to represent vectors in R2 and R3 using pairs or triples of real numbers. So let's get to our position vectors first. I'm going to give you the definition again, like we did yesterday. A vector which has a tail at the origin and the head is located at some other point in the coordinate system. So far it's the same thing. In R2, we're going to use that vector lowercase b. Look, notice that I always use a lowercase b, and it should have an arrow on top. So since I didn't put one in, I'll put one in now. Right, same thing here. So the components of the vector a and b, where a, b is the point at the head of the vector. So it goes from 0, 0, 0, the origin, to some point a, b, and then the vector a, b is these components. In R3, we use triples. So a, b, c, where ABC is a point at the head of the vector. And we can sketch vectors in R3 using a rectangular prism, which is what I'm going to do right now. And it follows the same convention as yesterday. So what do I mean by that? Well, before we get to R3, let's just finish up R2. Here's a diagram that shows OP, right? And OP is just simply the position vector running from O to P. The point P is the point AB. And these are the components here. It's 2 along this axis and maybe 2 along that axis that take it to that point right there. So again, nothing particularly different from what we did yesterday. There's a unique location on the XY plane. This point, this vector OP. If you're saying that it's a vector that runs from O to P, that has a unique position given its endpoint, the point AB. All right, nothing new there either. So now we're going to get to this so-called right-handed system. So 2 space is easy. 2 space we did yesterday. 2 space you've been doing for a while. 3 space is the one that takes you a little bit more time to wrap your head around. It forms what's called a right-handed system, which means that you point your index finger along the x-axis. So here's your finger pointing out of the board. That's your x-axis. Your x-axis is the one that goes out of the board and back into the board. The y-axis, which is what I was showing yesterday, is the one that goes from left to right. And the z-axis is the one that goes up and down, right? So that's your z, that's the third axis. So x-axis is the one that's moving towards you. The point, the side of the x-axis that is coming out of the board is the positive side. The negative side is the one that's going into the board. The left side is the negative side of the y-axis. The right side is the positive side of the y-axis. The top side is the positive side of the z-axis. The bottom side is the negative side of the z-axis. Okay? All right. So the YZ plane is the plane of your piece of paper. So this is the piece of paper that you would be saying, and the x-axis is actually coming out towards you. All right. And again, I'm showing you these axes lined up in what I'm trying to show is a three-dimensional manner. It may not look very three-dimensional. You have to use your imagination to see the three dimensions. All right? Okay, so having said that, let's get to the first one. Sketch the vector in R3 is useful to use a rectangular prism that contains a point ABC. And the point ABC is at one of the corners of this rectangular prism, opposite to the origin. So here we go. Determine the coordinates of C, D, E, and F. We're going to do that right now. I'm going to be calling on one of you in a minute to help me out with this. So look at that diagram very carefully. I'm trying to give it a three-dimensional perspective. Here's my 0, 0. The point ABC is somewhere in this corner of this prism right here. So let's name C with triples, right? So it's a point. It's not like I'm trying to draw a vector. It's a point. The point C is right here. So it looks as if I moved to a point along the x-axis, which gives me therefore the coordinate A. It looks as if I have moved up along the z-axis. So I'm going to give that the coordinate C. But it looks as if I did not move at all along the y-axis. So I'm going to give that a 0 coordinate. All right, let's see if everybody is okay with that. That C point is AOC, meaning I've gone forward on the x-axis right here. So that's the A component of this ABC right here. I've gone forward on the A-axis, on the x-axis. I've gone up on the z-axis, and I'm right there at C, but I haven't moved along the y-axis, right? I'm still in the same place along the y-axis. I haven't moved on the y-axis at all. So the point C, uppercase C, I want to make sure this looks like an uppercase. The point C is AOC, and the O is actually a 0. It's A on the x-axis, 0 on the y-axis, and C on the z-axis. Okay, hope everybody followed that, because we're going to do some more now. I'm going to do one where I'm going to ask one of you for your answer in a second. Let's go to the point D now. All right, I need a triple for the point D. Look at where D is. D is up here. So if I start at the origin, the only thing I've done to get to D, can I repeat that again, please? I sure can, Taj. I sure can. Yeah, let me go back. I don't want to go too fast here. I want to make sure everybody's following me here. The C point is this point. Let me circle it. Look at where C is. C is right here. How do I get to C? To get to C, hold on, Thomas. To get to C, I'm going to move along the x-axis, right? A units along the x-axis, right? This point here up here is ABC. So I moved A units along the x-axis, and I moved up C units along the z-axis, but I didn't move on the y-axis at all. Right? The y-axis goes left to right, and I'm still in the same place laterally. So along that lateral axis, I haven't moved at all. Does that make sense, Taj? How I got the A0C? Okay, good. Now we're trying to get, so let me erase the C. And I see an answer there from Thomas already. I'm trying to get the D point, and the D point is up here, right? That's where the D point, oh, sorry. That's where my D point is. So it looks like to get to D, I've only done one thing. I've just gone up from my origin. So it sounds like I really haven't moved along the x-axis. I haven't moved along the y-axis, but now I've also moved C up on the z-axis, exactly what Thomas has there. If you look at Thomas's answer, you see what I'm talking about. So it's 0, 0, C. Okay? All right, so I'm going to be asking one of you now for the E-axis, for the point E. I'm going to go back up to the diagram. Don't put anything in the chat. Whoa, 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 folks. Whoa, whoa, don't put anything in the chat yet. All right. Okay, Thomas, hang on. That's that guy. Somebody hold Thomas for me, please. That's kind of hold him down there. He's out of control over there. He's ready with all the answers. All right. Let's get to Ashvan. Ashvan, are you there, Ashvan? Ashvan, we need you. Where are you? Hold on to your, okay, Ashvan. Look at where the E is. I'll circle it for you. All right, the E is right here. Think of how you're going to get to that E, looking at all of the components that take you to that E. All right, give me the triple that takes you to the E. Make sense what I'm asking? Go for it. All right, go. How do I get to that E? using 3 coordinates. A, B, and C take us to that far point. Let's hear what you got. So let's see what you have. You have F. Where did F come from? It's either A, B, or C though. So you can't use F. There are only 3 possibilities, A, B, and C, and zeros. So there are three letters that we have, A, B, C, but also if you haven't moved along one of the axes, then you can use 0, if that makes sense. All right, try that again. How far along the A? How far along not the A, sorry. How far along the X? How far along the Y? How far along the Z? Look at the examples. Thomas is, oh wow. I should just turn this thing over to Thomas. Let's hear what you got this time, Ashwan. Right, just think, how far did I go on the x-axis to get to that E point, the one I just circled? How far did I go along the y-axis? How far did I go along the z-axis? Okay, so I'm seeing B0C. I'm going to write that down. We'll talk about whether that makes sense. B0C. So what you're saying is, I've gone B along, and you have B here. I mean, this, just so you know, the first letter should be an A only. See the A or 0. I'm just saying, Ashwan. I'm just saying. Carly, could you hold off for me, please? Just hold off for me, please. There should never be a B in this column because the only thing you can have there is either an A or a 0. So do you mind if I erase that, Ashwan? All right. And let's replace that with something else. He was close though. Okay, well, we'll see. Why is that? Because, okay, let me tell you why, and I'm glad you're asking. This point, let me erase this part right here. This point right here is the point ABC. That's the furthest you can be away from the origin. Okay? So that's A along the X, B along the Y, and C along the Z. Okay? So A has to be either it's like the X, Y, and Z. It is actually X, Y, and Z axis. Absolutely, absolutely. So the furthest you can get on the X axis is A, or it can be 0. The first you get on the y-axis is B, or it can be 0. The first you can get on the z-axis is C, or it can be 0. I'm thinking the y-axis is okay. Right? No, they're not. No, they're not. So let's try that again. So I'm going to erase this, and I'm going to circle again the E, which is the one we're working on now. Okay, so let's try again. So should I keep that 0 and that C, or tell you what, let me erase everything. I know some people say you were close, but I just want to make sure I give you a clean slate to start again. What's the x coordinate? What is the y coordinate? And what is the z coordinate? Okay, I'm going to write that down. So you're saying now it's 0, B, and C. How does the rest of the class feel about that answer? And let me ask the question a different way. How does Thomas feel about that answer? Thomas seems to be, really on top of this stuff. Thomas, what do you say to that? You're confused. Okay, all right. Okay, Thomas says it's good. Thomas gives it a thumbs up. All right, so let's do this, Ariana. Okay, let's move from the origin and try to get to that point. What axis am I going to go along? Tell me which axis I can go along to get to that point up there. Which axis am I going to go along? I want to get up to here from the origin. Where am I going to go? Tell me how to travel there. Tell me how to get there. Ariana, can you help me out? I'm not sure. Well, there's a couple of routes. I mean, think about it. Okay, so I want to start off here and I want to end up over here. You see where I'm trying to get to, Ariana? I want to get up to E. Okay? So tell me some lines I can travel along to get there. Give me some lines I can travel along to get there. Which axis, in other words? Tell me what axis I can go along to, I can move to get there. I want to get from A to E. So what axis am I going to travel along? Look at where E is. Could you go up? Okay. Okay. That's along the Z axis, right? Would you agree? That's along the Z axis. Okay. Once you get there, what direction are you going to go in? Are you going to come out of the board? You're going to go left? You're going to go right? You're going to go right. Which axis is that? Which axis are you moving along? The y-axis, correct. Am I moving along the x-axis at all? Am I coming out of the board or going back into the board? Am I doing that at all? Okay, so that's why there's a 0 in the first position. I'm not moving along the x-axis at all, right? But I'm going full along the y-axis, and I'm going full along the z-axis. Do you see that? So I have to go a full B along the y and a full C along the x, because I need to go up and across. Up means I'm going along the z-axis. To the right means I'm going along the y-axis. Does that make sense now? Okay. Why are we using B and C as the values? Okay, because they said that the furthest point that, and when you get to the other one, there's going to be a difference because we use actual numbers. The furthest point that we can get to, let me erase this. The furthest point that we can get to is this point right here. That's going from the lower corner, which is where the origin is, to the upper corner, which is where this point of P is. I can't go any farther than that. And for that, I need to go along all the axes to get to that point. I need to go along the X, the Y, and the Z axis. Okay? That will take us the furthest we can go. If I'm only going to go along one axis, then I could either, so let's say I'm going to go along, okay, let's do it this way, Ariana. If I just wanted to go along, let me erase this. If I just went along one axis, I could either go from here out to here, from here to here, or here to here. That would mean that I've only traveled along one axis. So it means that the other axes would be 0. It would be 0 along, let's say, for instance, I was going to use this as an example, right? Getting to Y. To get to Y, I can only travel along the Y-axis, which means that my X-coordinate and my Z-coordinate would both be 0, right? And how far am I going? Well, because the furthest point is at ABC, it must mean I went all of B along the y-axis, right? Because B is the furthest point. B is this point right here. Oh, sorry, you can't see that. B is this point right here. So I've gone all full B. Okay, great, great. Let's do one more. All right. I sense that Thomas is ready to go on this, and I don't want to hold him back. So, Thomas, let me erase all this junk I have on here. 1 second. Can you tell us how to get to the point F, Thomas? I'm not going to say anything more. I'm just going to turn it over to you. What do I put in to get to the point F? Okay, Thomas, it's all yours. 0, B, 0. I'm going to write that down. Oh. Okay. What do other people think about that answer? Fernando got that too. How about other people? Taja and Sarah and Aria. Okay, good. Good, 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 good. So we've traveled a full B along the axis and we haven't gone anywhere else. We didn't go up. We didn't go into the board, out of the board. We didn't do it. We just traveled along the y-axis. So every other coordinate is now 0. Okay, hopefully that makes sense. All right, I'm going to move over to my next one now. Tomleo got that as well. And now things are going to be to sketch the vector 2, 3. So the way I thought I would do this to hopefully for you to make sense of this. Remember, let me bring this down some. Remember that the x-axis is the one that's coming out of the board, right? Going back, coming out of the board. The y-axis goes left to right. The z-axis goes from bottom to top. Okay, all right. So the point 2, 3, 4. So 2 along the x-axis, 3 along the y-axis, and -4 along the z-axis. So let's try to think of where, I'm going to try to position this in a way that makes some sense of this, right? So 2 coming along here, 3 going along here, and 4 going down here. So I'm going to say that that is going to be somewhere around here is what I'm going to say. I'm going to see if this makes sense to everybody, right? Let me move this down a bit. Oh, sorry, I didn't mean to. Let me move this up a bit, actually. Now, let's see if this makes sense to everybody, right? The point that I'm calling 2, 3, 4, which is at the end of the vector, should be some distance along the x-axis, right? Some distance along the y-axis. In fact, this is 2 this way. So let me mark it. It's 2 going this way. It's 3 going this way. And it's 4 or minus 4 going down this way along the z-axis. Does that look about right to you folks? So it means that the point that I'm calling 2, 3, 4 is this corner right here. So the vector that I'm gonna draw in, I put it in red, is a vector that looks something like this. Right? I want to make sure everybody can see what I'm saying here. Right? I put that box in this little part here to represent 2 going this way, and this is what I'm calling the v vector, by the way. Little arrow on top. This v vector, position vector, runs from the origin. It's going 2 forward, it's going 3 to the right, and it's going 4 down. All right, is everybody kind of seeing what I'm saying here? Does that kind of sort of look right to you? I use that little box to give it a 3-dimensional kind of look to it. Okay, so what I also did to help you to see that is I showed you GeoGebra yesterday, which is a program, a website really, that allows you to have a 3-dimensional perspective of things. Maybe not the best, but that's the one I've been using. So I'll show you what this looks like on GeoGebra, right? So here's a vector on the side here. The way they represent a vector on GeoGebra is they put it as a column of numbers. So here's my 2, 3, minus 4. And this is so notice I'm using a lowercase letter to represent the vector and an uppercase vector to represent the point. So let me show you what that looks like now. Again, it's pointing down here, and you can see it's labeled as the point 2, 3, 4. And then you can see, hopefully you can kind of make it. I can make this bigger, actually. You know what? Let me put this on another page and make it bigger. Hold on. Hold on. I'm going to copy this onto another page. Or actually, what I can do is just zoom in on this page. Let's do it that way. Zoom into 300%. Okay, so there you can see. The point is 2, 3, 4, and it's kind of where I should. This dotted line here is kind of showing that there's a plane, right? This is actually referred to as the XY plane. This gray, like flat surface is the XY plane. And then you have the vector pointing down, and part of it is dotted because you're kind of saying that you can't really see this part of the vector because it's being blocked by the plane, and then it becomes solid again after that. But here it is pointing down here, which is 2 along the x-axis, 3 along the y-axis, and minus 4 along the z-axis going down. Okay, try to give you some perspective on that. Okay, all right, I'm going to have to shrink this back again because that's way too big. All right, so there you go, folks. Let's give you some perspective on that. And again, lowercase letter for vector, uppercase letter for a point. And the position vector is running from the origin out to the point up here, 2, 3, minus 4. Let's try the next one. Okay, now I'm going to make this a little bigger. So I'm trying to find a way to put this box now, right, to give it a 3D perspective. I need to be 5 along the x, minus 3 along the y, and 2 along the z. Okay, so watch where I'm going to put this now. Watch where I think this makes sense for us to put this. Right, I need to put this like about here. Like about there. Trying to line this up properly here. Right? So what I'm saying now is I'm coming this way along the x-axis, that's the 5. I'm on the negative side of the y-axis because the middle component is negative, and I'm going up along the z-axis, which is why this is. So I'm saying that the point T to create this vector is this point right here, and the vector would run from here up to here. That farthest corner right there, right? That's where the vector is running. I'm going to call that the vector T, and I'm going to call this point right here 5 minus 3, 2. So what I'm trying to do is show you that this vector, this point I should say, in space is 5 forward along the x-axis, it's minus 3 along the z-axis, along the y-axis, and it's 2 up along the z-axis. That's the far corner. It's always the far corner when you have all 3 of these here. Okay, so 5 minus 3, 2. All right, so again, I'm going to show you what this looks like on GeoGebra, right? And let's see if we can unveil that. I'm going to make this bigger again. It's in the same kind of position that I just showed you a few minutes ago. Okay, so again, notice that the lowercase letter represents the vector, and then they put it in a column. The uppercase T is a point, 5 minus 3, 2. And here's the point right here, sort of in the same place that I put my vector a few minutes ago. So it's forward along the x, to the left of the y-axis, and it's on the top of the plane, the xy plane, because I'm going up along the z-axis. You got to try to think 3D. That's the whole idea here, think in a 3-dimensional manner. Okay? So hopefully that gives you some perspective on that. Let me now go to this diagram here. I'm going to change the view again. Go back to maybe 150%. Oh, maybe that's too small. Maybe we'll go to 200%. Okay, so let's think this through now. In the following diagram, and I'm going to come back to the class now, and not just Thomas. Not Thomas can't do the work for everybody today. In the following diagram, the point 624 is located in R3. All right, so here's 624, right here, where I'm pointing to right now. Right, so it's 6 along the x-axis, it's 2 along the y-axis on the right side, and it's 4 up. That's what this point is right here. What are the coordinates of all of these points right here? I'm going to grab my wheel now, right? It's wheel time, time for the wheel, wheel of anxiety, wheel of whatever you want to call it, right? And I'm going to call out how many of them? 1, 2, 3, 4, 6 of you in a minute to help me out with this. All right, so just stand by there, folks. Start thinking of where A is, where B is, and we're going to draw the vector OP. And I put the vector in afterwards. I just want to see if I can get some coordinates out of this first. All right, so this is the MVC course. And I probably should have, all right, anyway. First up is Sarah. Sarah, can you first of all check in for me? Danny is, oh my. Sarah, can you check in? Not Sarah, but Sarah. S-A-R-A-H. Right? I get the two sometimes. I mispronounce them sometimes. Okay. So look at the point A for me, please. The point A. See where A is? Can you give me some coordinates for A, please? Remember, the furthest point is 624. Right? But what I'm trying to figure out now is the point A. So I'm going to circle that for you. Probably don't need me to do it, but I'll circle it anyway. Give me what you think are the coordinates of A. It's a triple. What do you think those coordinates are? So 600. I'm going to write that down. Followed by a question sign, where it says Sarah is not 100% sure, but she thinks it's 600. And I am sure that you're right, Sarah. So I'm going to confirm that for you. Is anybody who still wants me to go with that, or is everybody comfortable with that? The only way that I've moved on this to get to A is by coming forward along the x-axis. I didn't have to go up, didn't have to go right, didn't have to go left, didn't have to go down. I just slid along the x-axis and that was it. All right? Everybody comfortable with the first answer? We're going to move on. Look for B now. I'm going to go back to my wheel of, I'd say, I don't know, wheel of anxiety doesn't sound right to me, but anyway. So Sarah is good for today. And let's see. This looks like Fernando. Fernando, check in for me, please, Fernando. Wow, that didn't take long. That did not take long at all. Let me first of all erase this. And B is this point right here. And you're saying it's 620. Let me write that in. Let me write that in properly. So Fernando was out to the no, not even there's not even a question sign there, Fernando. Like you're saying, I got this, right? I don't even have to question this. 620 sounds good to me. Well, how does it sound to the rest of the class? That's my question. 620 sounds good to you too? Okay, all right, good. So clearly we're making some headway here. Let's get to C. And for C, Fernando is good for today. We're going to go all the way to F, by the way. That goes to, look at that, it goes to Thomas, the expert of experts on this. So Thomas, I know you've been asked a question before, but the wheel has chosen you anyway. So Thomas, can you give us the coordinates? Let me erase B. Can you give me the coordinates of C, please, Thomas? Go. And we'll ask the class what they think afterwards, but only Thomas right now. Where is C? How do I get to C using only those points that we have there? So 6, 0. I'm going to write that down. Oh. And let's ask everybody else what they think. Does 604 sound okay? Oh, wow. Good job. Okay. All right. Let's get to D. And for D, thanks, by the way, Thomas. Good job. You heard somebody else say that to you. I need someone to tell me where D is, and that goes to Jessica. Jessica, step up for me, please. Your time. Are you there? Jessica, good. Jessica, can you tell me where D is, please? Did you mean to circle it, or you think you're good without it? Do you have an answer for us for where D is? You're okay. Oh, excuse me. Let me back off here. No, Jessica says, I don't need your help, Mr. Kamakai. I got this. Where is D? 0, 0, 4. And that's what everybody else got? 0, 0, 4? Same here. Okay, all right. Okay. This clearly is not a challenge for anybody in the class. Not at all. Not at all. Okay. So that was Jessica. 2 more. Excuse me. We need to get the E vector, or E point, I should say. Sorry, E point. That goes to Umair. Umair, check in for me, please. Looking for E. Okay, go for it. Where's E? Where is E? How do I get to the point E? And as usual, if anybody needs help, you just have to ask, and I'm quite happy to give you that help. Let me circle that E for you, by the way. 0, 2, 4, he says. Does that sound right to everybody? 0, 2, 4. So we're not moving along the x-axis at all. We're stuck on the x-axis, but we do go to the right by 2, and we go up by 4. Good. Okay, one more. F. All right, now for S, yeah, thanks Adam, thanks Carly, thanks Fernando. For F, we have one other person left to harass here. That's not the right word, but that's the word I'm going to use anyway. And that would be Kashaf. Kashaf, can you tell us, Kashaf, check in for me first, please. And then after you do that, tell us where F is. Go for it. I'll erase that and circle the F. 0, 2, 0. All right, you know what? Because everybody has been so expert at this, I'm just going to move along. Folks, we're going to move along. I think you've all figured out how this thing works, so that's good. All right, let's get to this. In the following diagram, oh, and they did ask us to draw in the vector OP. Vector OP just simply runs from here to here, up to that point right there. All right, that's hopefully easy enough. All right, in the following diagram, the point T is what is the coordinates of PQ? Okay, draw the vector OP. All right, we're gonna skip this for now, all right, because there's something which we have to get to before the end of the class, and we're already 20 minutes to the end of the class, and that's this thing here. No, this is exactly the kind of thing you need to be able to do on your homework. So let's just focus in here. The point Q is this point down here, 2 minus 3 minus 5. All right, write an equation for the xy plane. Now, the xy plane, I'm going to remind you, I'm going to try to color it in for you. Folks, this may not work out very well, but I'm going to try to color in the xy plane for you. It's this area right here. This is the xy plane right here, right? Think of it as a flat surface, Now, what would be, remember when you were, let me remind you of something. Let me take you back to your grade 8 for a minute, or maybe grade 9. If I drew in a perfectly vertical line, which goes through, let us say, 7, what would be the equation of that line? Perfectly vertical line. Can somebody tell me what the vertical line equation is? Because we're trying to find an equation for that plane. So what is the equation of that vertical line? Come on, folks. You did this in grade probably 9. That line has an equation. Every time I ask for an equation, like an asymptote, right? A vertical asymptote is the x equals, thank you, x equals 7 line. And I'll tell you why it's the x equals 7 line, because every single point on this line, let's say this is the point, I don't know, 7, 5. Let's say this is the point down here, 7 minus 2. This is not drawn to scale or anything. What's common is that every single point on this line has the same x coordinate. Now, on the other hand, if I drew a horizontal line that went through, let's say, for instance, 3, what would be the equation of this? Y equals 3 line. Thank you very much. That's because every single y coordinate on there has the y. Every single point on that line has the coordinate 3. Okay, all right. Think about the xy plane now, right? And I tried to kind of show you that xy plane is this kind of flat surface that sits on the y-axis is here, the x-axis is here. It's like a piece of paper that's sitting flat on that xy plane. What do you think would be the equation of that plane? Planes have equations, right? Just as how a line can have an equation, a plane can have an equation. What do you think is the equation of that plane? Look at what's common to every single triple. Every single triple on that line would have something in common, which would help you to name that, not line, on that plane, sorry. Every single coordinate, every single triple that sits on that plane has something in common with it. Can anybody think of what that is? Because that would be the equation of the line, of the plane. Anybody think about the equation of that plane is? All right, that flat surface, it's not the equation of a line, it's the equation of a plane. We'll get to equations of lines. It's the equation of a plane. right? Can you think of what that equation might be? Think of every single point sitting on that plane. I don't see any answers yet. Right? I don't see any answers yet. Nobody can think of an equation. Ah, there you go. There you go. It's a z equals 0 plane is what that is, right? Because every single point that sits on that plane has a z coordinate of 0. Hope everybody can see what I'm saying here, right? That takes care of the first one. Write an equation for the plane. So that's right, that's good. Let's see what we can do for the second one now, right? And we're kind of running out of time here, 15 minutes to go. Write an equation for the plane containing the points P, M. So it's another plane. I'm going to erase this plane. So a plane is a flat surface, right? So whereas in two space we have a line, we can have a plane that slices through the 3 space. So this plane contains the points P, Q, M, and T. So here is P, here is P, here is Q, here is M, and here is T. So it's really, if you think about it, this is one piece of that flat surface. That rectangle that we just drew, right, is sitting on that plane, right? It's not the whole plane, it's just part of the plane, but it says write an equation for the plane containing those points. So all of those points are sitting on that plane. What would be the equation of that plane? The PMQT plane. And I see what Jordan has there. And Jordan is right. In fact, let's look at all the points that are sitting on that plane and see what's common to all of those points, right? This is 0, -3, 0. This is -2, 3, 0. This is 2, -3. What's common to all of those is that they all have a y coordinate of -3. So not y equals 0 this time, Sarah. It's what Jordan has. It's a y equals -3. Does that make sense to everybody? Right? I want to make sure that everybody follows that. The equation of that plane, not the y equals 0, the y equals 0 would actually be the plane that would be along the xz plane. Right? That would be the y equals 0. But this one is moved to the left. So that's why it's the y equals -3 plane. Okay? Does that just want to make sure everybody's following that, because I want to make sure we finish this before the end of today. All right, everybody okay? Cyrus says yes, but what about everybody else? Does that make sense to everybody? All right? Okay, great. Okay, perfect. Let's keep going. Let's keep going. I'm going to erase this, and erase this, and erase that. Okay, watch this one carefully. Write a mathematical description of the set of points in the rectangle. So the same PQMT, but now we're saying I don't want the whole plane. I want to restrict it to the points that are sitting on the rectangle. So in other words, what I had there before, I want a way to describe only that plane that would be restricted to that rectangle, the set of points that are on that rectangle. Well, in order to make it easier for you, I'm going to write it, I'm going to just give you what the answer is, okay? The best way for you to describe it is not just the y equals -3 plane, it's this. It's x minus 3z. So in other words, all of the points have -3 in them, but you're saying all the x's now are restricted to real numbers between 0 and 2. And I'll show you why it's between 0 and 2 in a minute. And the z's in this, right, this is how you're describing it. All the z's are real numbers between -5 and 0. Why am I saying this? Let's go back and look at that rectangle. That rectangle does sit on the y equals -3 plane. Yes, it does. But it's not all possible x values, and it's not all possible z values. The let's start with x first. The x values, look along the x-axis, go from 0 to 2, right? So from 0, it starts off at 0 and it stops at 2. So we're saying your x values can only be between 0 and 2, square brackets, because 0 is included and 2 is included, right? So all real numbers between 0 and 2. Your y values now to get to my y's along the x-axis, along the y-axis here, can be anything from 0 up to the, not y, sorry, the z values. I'm sorry. Why do I have, this is wrong. I need to fix this right now. It's not y. Crap, I'll have to fix it another time. This was meant to be z. Sorry about that. That's meant to be z. My z values now, right? So I'm trying to figure out all of the possible z values. Start at 0 and go all the way down to the -5. So those are my possible z values, right? So all the way down to -5. So it's x minus 3z is the way I would phrase this. Whereas the x's, all these x's that I'm going to be putting in come from the 0 to 2. And all the z's, that's going to be a z, come from the -5 to 0, right? Including -5, including 0. Now, last one. What is the equation of the plane? So I get an equation of a plane that's parallel to the xy plane. Remember, the xy plane we said before was the z equals 0 plane. When we answered that question before for part 8, was the z equals 0 plane. So what's the equation of the plane that's parallel to the xy plane, but passing through R, and R, let me erase all of this. The R point is this point right down here. So remember, it's going down along the z-axis. So here's the R point down here. So it's an xy, it's parallel to the xy plane. Xy plane, remember, was this area right here. That's the xy plane. And I want that plane now to be parallel to a plane that has this point in it down here, right? So what do you think that equation of that plane would be if it is all the way down here, but parallel to this plane up here, right? Okay, Vanessa and Sarah hit it out of the park. Hit it out of the park. It's a z equals -5 plane. Okay, that's it right there, right? It will be parallel to this z equals 0 plane, but if you drop it down to here, all of my z values are going to be -5. Okay, there'll be different x values, there'll be different y values, but all my z values are going to be -5 along that plane, right? Now remember, if I wanted to set a rectangle just within a certain part of a plane, then I can say it's x and y, those are changing. The -3 is constant, and then I can define my x and I can define my z as being belonging to a particular set of real numbers. So in this case, it was 0 to 2, and it was -5 to 0. Okay? All right, so I guess I squeezed all of that in because this is exactly what your homework is about. I just want to make sure that I got that in. I don't think we really need to do this one here, but I'll just do maybe 2 of these and then we'll wrap it up from here. The following diagram, the point T is located in R cubed. What are the coordinates of P, Q, R, and M? So I'll pick out Q and I'll pick out S. And we'll just get 2 people to volunteer. I won't go to the wheel on this one. Give me the coordinates of Q, somebody, and give me the coordinates of S. So I need 3, I need a triple for both. And after that, we're done. All right. So who can tell me the coordinates of Q? So remember, the furthest point in this case is -3 to -2. Me, Kushi says, okay. And well, Fernando is, whoa, you guys are so quick on this thing here. I'm going to write down what Fernando says. She put 0 to -2. I'm going to write that down. 0 to, let's see if that's right. Q is down here, right? To get to Q, I need to go down along the z-axis. So that means that -2 makes sense. I need to go across on the y-axis. So that +2 makes sense. But I'm not actually moving along the x-axis at all. So 0, 2, -2 makes perfect sense. Okay? And Ariana, okay, Ariana is saying, okay, looking at the wrong thing. Yeah, probably. Okay, all right. Okay, and finally, to cap this off, let's just figure out where S is. I'll take a volunteer on the S. Sarah's thinking -3, 2, 0. I'm going to write that down. -3, 2, and 0. Okay, excuse me. So S is in this corner right here. To get to S, I'm going to go back along the x-axis in the back. So that's the -3 there. I'm going to go across the y-axis at 2. So that makes sense. 2 to the right, that is. But I'm not moving along the z-axis at all. So it should be 0. Okay? Kushi, I think Sarah beat you to the point. Never mind. Never mind. So we've got some brilliant vector specialists in the class. That's pretty good. Who are capable of thinking in a three-dimensional world. So hopefully especially the last example, right? You're going to retain that. Sorry about the mistake I have there. That you should now be able to do that homework fairly easily.